Lee. I'm one of the dozen or so volunteers for the San Francisco Bay Area ACM, or Association of Computing Machinery. Tonight we have a webinar that's Analytics and Data Science, Standardization and Assessment Framework. So we have two excellent speakers, Usama Fayyad of Open Insights and OODA Health, and he's also the IADSS co-founder, along with Hamachu. So I've got a few introduction slides I'll have about ACM as an organization and this local chapter, and then we'll have our speakers start. So the San Francisco Bay Area ACM was founded in 1957. So we're one of the older local meetup groups. We have a $20 annual membership fee, so we keep the cost low. We have 2 monthly meetings. There's a general computing talk, typically the 3rd Wednesday of the month, and a data science SIG or special interest group, usually on the 4th Monday of the month. We like to promote networking, job announcements, other kinds of working with different societies. Due to the COVID pandemic, we're working on webinars for April and May, and we'll follow whatever the directions are as far as good social distancing for events in place or events that are webinars. Some upcoming events. So Monday, May 18th, Ethical Dilemmas in Artificial Intelligence and Privacy from Stanford University. And then Monday, June 22, Enterprise AI, the most untapped opportunity for novel and impactful AI work by Medhi of C3 AI. So you can use the Q&A in Zoom for questions. There's a chat. So if you go to chat, you can send messages, and then people in the meeting can see that. You can also raise hand. So please be careful to speak closely to your PC for better recording. So now I'd like to introduce tonight's talk. So what is data science? Who is a data scientist? Who is a data engineer or an analytics professional? Professional disciplines use a mix of applied statistics, management science, and computer science. The demand for data science skills parallels the investment in data, which is growing tremendously. Future demand for data scientists may exceed over 23 million in the US alone. There's a confusion, or 2 to 3 million in the US alone. There's a confusion on the basic definition of tools, methods, skills, and roles, as well as what is the definition of data science and data scientists. So which skills should we count as important? What is a level of skill needed to qualify a data science professional? Who is a senior data scientist? So this is something that employees, employers, and universities could benefit from clarity in. So Usama is the co-founder and CTO of OODA Health. It's a VC-funded company founded in 2017, focusing on AI automation to create a retail-like experience in payments processing in the healthcare industry. He's also the chairman at Open Insights, a consulting firm founded in 2008. He also has published over 100 technical articles on data mining, data science, AI, machine learning, databases. He holds over 30 patents and is a fellow of both AAAI and ACM. He earned his PhD in engineering in AI and machine learning from the University of Michigan and in Ann Arbor. So he's edited 2 influential books on data mining. Hammett is also a board member in general and investor in a number of organizations. He's the other IADSS co-founder. As you can see, it's the Initiative for Analytics and Data Science Standards. So he has more than 20 years of industry and consulting experience in areas of customer strategy and advanced analytics. As a consulting partner, he's built and led cutting-edge analytics practice, hired, trained, managed hundreds of consultants and data scientists, and led large transformation projects in the US, Europe, and emerging markets. So now I'd like to turn it over to our speakers. So I'll stop sharing my screen. So Usama, if you're going next, go ahead and share your screen.
Thank you, Greg. I'm still unable to turn on video for whatever reason. I have been disabled by the host, I guess.
Oh, I'll check to see if there's something I can do in my controls.
But in the meantime, we can get started. Thank you for the introductions and thank you for inviting us here. The introduction included my being CTO at OODA Health. Actually, back in May, I transitioned into an advisory CTO role after helping co-found the company and launching it, etc. I'm still an advisor to OODA Health, but I'm 100% of my time on Open Insights, which also is one of the major sponsors as a company of the initiative called IADSS, which you will learn about today, but you'll see a lot of the results we'll present today. So Greg, let me know if you ever enable the video. Otherwise, I'll just apologize and show slides only. Hamid will be also my co-speaker. So at one point we will hand off and I'll continue driving the slides. So why are we doing this? And why are we talking about this license to analyze? So let me at first start by motivating it. Do you believe a pilot needs a license? And who would you trust to pilot a commercial plane? Like this guy, Captain Sully, who actually could react correctly, etc., or these jokers from airplane, right? The point is that we actually expect professionals to be trained, to be qualified, to be evaluated, to kind of be able to label themselves. Pilots or doctors, right? And you have many examples and articles on doctors who are not qualified doing stuff, especially in plastic surgery. Do we think this applies to data? And is data as important as piloting a plane? I would argue in many cases actually that it is. Are you getting the right value from your data assets? That could actually make the difference between surviving and failing. What happens when you get the wrong outcomes from doing data? And what I would say, and especially relevant to our day and age, if anything, the reaction to this coronavirus has pushed us all into kind of lockdown. Whether you agree or disagree with that philosophy is a different story, but that reaction has actually done one thing, which is non-reversible, in my opinion. It has accelerated the digitization of everything, right? So, anything, plug in what you like, commerce, health, government, whatever, has gone electronic, and people have realized that this is a very effective, digitization is a very effective and very resilient approach to take, especially in these times. Now, with that push into digitization, you suddenly live in a world where if you do it without having the data at your fingertips, without being able to understand what is happening on your digital channel, be it a website, be it an app, be it any kind of digital interaction, without it, you are blind. You don't actually understand what is working, what is not. Are customers succeeding or failing at getting your services? What services work, what services don't? What do you do about it? How do you get people to kind of join your service, etc.? So in a digital age, is the short story, data becomes essential. It becomes essentially your eyes and ears and everything that you need to kind of know what to do and how to react to what's happening in the market. Data science has been a hot topic. I will spare you, the details of each of these, but it's been winning kind of the sexiest job or the hottest job in surveys of Glassdoor for many years. It's highly coveted. Companies want it. Candidates want to be it. The pay, of course, and because of the mismatch between demand and supply or availability of qualified data scientists, has of course driven compensations up. So, the economically rational thing to do is, if you work in a field that has anything to do with data science, to call yourself a data scientist. The problem is, those who are hiring you may be having a different expectation than what you're qualified to do. And we don't necessarily blame you, because nobody's clear about what do they expect, right? They have it in their heads. They haven't figured out how to put it down into job descriptions and how to specify roles, etc. So those definitions are very much needed. The number of analytics professionals in general is growing, pretty dramatically. Actually, it is estimated to be above 3 million today, and it's been growing at a CAGR of 120%. This is basically going to people with memberships and or use of Kaggle. Obviously, you don't go to Kaggle unless you have some kind of analytics task in mind, or you're doing something that has to do with data analysis and data science.
Usama,
Yes?
go ahead and try to turn on your video. I think it should be enabled now.
All right. So do
Very
you guys see me?
Yes, I do.
All right. Good. So good to see everyone. A quick, just continuing on, besides, sorry, this thing, okay. Besides the growth on Kaggle, a multitude of groups are growing in size and membership. There's, in a recent research we've done maybe 6 months or 9 months ago, we found 26 million plus LinkedIn members who have a capability targeting that has something to do with data science, be it machine learning, data science, data warehousing, big data analytics, data analysis. I've listed them here. There's about a million global LinkedIn members who carry that title that has something to do with data science, analytics, BI, etc. Right? Also, the definitions by groups or by affiliation, right? Some of these groups may or may not be valid in our opinion. Nevertheless, they are there and they have memberships, right? And these memberships are fairly large, right? And some of these are fairly legit. I mean, I belong to some of these groups, and I know some are kind of questionable, but we're not here to pass judgment. The point is, there's basically in the top 100 LinkedIn groups, the member base in groups that are related to data science is about 2.6 million. So again, the scale is larger than, at least for me, when I started kind of researching this area, and more than what many expect. If you ask the question, how many data scientists are there in the world, right? CEO of Kaggle basically said in groups, the member base in groups that are related to data science. Greg, I'm hearing myself come back, so I think that's a delay feed. Okay, can you hear me?
Yes.
Okay, there are between 1.5 to 3 million data scientists in the world. This is 1 year old statement by Anthony Goldblum of Kaggle. My first reaction was, really, 100% variance from 1.5 to 3 million. But what's interesting is about 200,000 to 700,000, again, these high variances, and we'll see later estimates that get tighter and tighter, of new grads that join the analytics job market annually. In the US alone, data professionals will increase to about 2.7, or I should say, job openings for data professionals will increase to 2.7 million. These are openings. The annual demand for the fast-growing roles, like anybody who has to do with data science, developers related to data science, and engineers related to it, like data engineers, will reach about 700,000 openings annually. So despite these increasing numbers, there is still data science skills shortage, right? So I just said, we think there's like easily over 1 million, probably more like 2 to 3 million data scientists. However, if you look at the demand, it's actually far outstrips the supply going by top emerging jobs. An interesting two studies to quote here. McKinsey forecasted in 2011 that the US could face a shortage of 150 to 190K people with deep analytical skills by 2018. This is one of the few interesting times where McKinsey was right on. In 2018, LinkedIn verified this estimate and did a report where they found that the shortage is about 151,000 people. So right in that range that McKinsey gave back in 2011. Again, this is a shortage. So it's very important to define that. This means these are positions looking for candidates and unable to find candidates to fill them, right? So there's 150,000 basically deficit of, if you will, people qualified in the US to fill the role. Various studies also highlight how challenging it is to find the right people, right? And they're in different areas. This is one study that kind of quant crunch that put them into different groupings, right? They have the stabilizers, which are basically kind of what you would consider very classical kind of analytical skills. The escalators, who do kind of more advanced skills. The disruptors, which is where data scientists fit in, right? These are people who are using kind of the latest and greatest in technology. They're using machine learning at scale. They're doing a lot of kind of tool-heavy, computational-heavy analytics, as opposed to kind of the stabilizers and the escalators. And then the challengers, who are kind of coming at it from, and by the way, IT has been going a long way in adopting, thanks for companies like Splunk and things like that, in adopting these techniques. They've also been moving into finance and risk analytics, enabling a lot of these providers to be, or people, professionals, to actually increase in terms of addressing roles that are more difficult to find, right? You can easily find, or more easily find, an accountant, but finding an accountant who actually can think about analytical systems is harder. Finding one who can actually do analysis with finance data is even more rare, of course. The next slide talks about the skill gap related between the challenges between supply and demand, right? So this gap effectively not only is slowing down the potential contribution to the economy, as we will argue later, it's actually costing a lot of waste in organizations, and it's also, and this is the one that scares me the most, it is potentially doing something that might destroy the reputation of the field itself. What do I mean by that? I mean, as people apply for jobs, if the wrong candidates are applying because of the lack of clarity, right? If the wrong candidates are applying to the wrong jobs, then companies will be wasting their time kind of interviewing the wrong candidates. Not only that, so the yield from the interviews will be low, but worse than that is, let's say you succeeded and you hired somebody, but you hired the wrong type. What happens then is there'll be a major disappointment inside the organization, either a wrongful conclusion, hey, data science can't really do much for me, or this whole analytics thing is overinflated in expectations, or a downright kind of, this is all BS, let's go back to, some of the well-defined sciences, let's go back and just hire statisticians, let's hire OR people, and let's just not bother with this whole area. So, with that added expectation and the big compensation packages comes a responsibility to deliver. And if we don't deliver, we could actually kill the field. What we're talking about here is that the shortage of 150,000 people in the US, according to that LinkedIn report, coupled with an increase in job posts, coupled with the fact that these are scarce skills to begin with, right? Not many people know about big data, not many people know about these advanced analytics techniques. is kind of creating this unmet demand. And the difficulty in hiring and matching the expectation happens because 82% of these jobs are sort of requiring too much experience. And that's usually a phenomenon where you see people kind of asking for too much when it's not needed. HR recruiters are pre-screening and doing cutoffs, sometimes going unreasonable because they're sort of trying to hunt for a needle in a haystack. And the recruitment process is kind of ill-defined. And we'll give you examples of this, and we'll talk about what's wrong. Meaning too long, asking the wrong questions, asking irrelevant questions, sometimes frustrating the qualified candidates, puzzling the unqualified ones, etc. In addition to the shortage, we also have a variety in the skills. So here's an example, right? These are 3 data scientists at Facebook, right? Same title, same company. If you look at kind of their backgrounds, right? You'll find that their educations are so varied, and we're just using these 3 as examples, right? They're so varied that they could be from completely different fields, right? Some of them kind of come from industrial engineering and have studied optimization. Others may come from kind of information systems and management, and what they study there is not algorithms and linear programming versus somebody who, the last candidate here, had kind of studied other forms of business, etc. But they all land in one company, same job title, completely different probably roles and ability to deliver, right? Now, of course, if you go across companies, you see an even wider. So these are data scientists, but in different companies, right? One at IBM versus PwC versus GE Digital. And again, you look at the backgrounds and you find that, well, these guys, their training is kind of completely different, right? Completely different emphasis. Some are around databases, some are around machine learning, etc. Similarly, by the way, you see the same variance for job postings, right? So within company and across companies, right? So if you look at job postings for data scientists, listed here as 1A, 1B, and 1C, you'll see that like the qualifications and what you're expected to know and the kind of experience you have to have, even though the title is the same, are very different, right? And you see the same, by the way, with the whole data analyst expectation. But with data analyst, the problem is less severe because typically you don't have to pay as much as you pay for a data scientist, where the expectation is they know how to program and they do other things. Couple of anecdotal quotes here, and then later Hamid will share with you more quotes from our survey. This is as we were doing our research, this was a job searcher on Quora, kind of talking about his experience in terms of how was his interview. He's talking about a company. He didn't take that job, but he went with another one. But he basically said, look, I spent the whole day. Some were asking me about programming, some were asking me about algorithms, some were asking me about product-specific questions, right? Some were asking about SQL. And there was a little in common beyond that, right? And the formats varied a lot, right? So some interviews were like all-day affairs, back-to-back meetings with programming all day. Others were kind of quick meetings with a CTO. They assess you and they say, hey, you could be a data scientist. Some, had you write codes code on the board. Many had face-to-face presentations, etc. And some were kind of cultural and social, and do you get along with the team, etc. But if you look at it, this is somebody who kind of, by the way, the context for this is this person was pretty frustrated with that experience, because it was basically, there was no consistency in terms of what these companies were looking for, even though all of them were looking for a data scientist. From the survey that Hamid will talk to you about, this is one of my favorite quotes. In this case, I just shared with you something from an interview where this one is an interviewer, right? So this is the hiring manager. And he says, I just hired, we started with a data scientist, we started with 60. They thought they had a fairly well-described role. He eliminated 40, sat down with 20 screening calls, 5 interviews on site. This is very typical, by the way. At the end, none of them were acceptable except for 1. So from 60 to 1, right? This is a huge effort. And after the screenings, the one that actually made it to interviews, almost all of them failed on the math questions. There are many of them strong in engineering, but the math is rare, was his quote that I like. And I do agree, actually, math skills are pretty important for this role. If you go to schools, by the way, there are, well, now it's even bigger than this, over 250 programs in the US that offer graduate degrees in analytics or data science. And it's been growing dramatically, as you can see. So universities have seen the demand and started responding by saying, okay, we'll train the people. However, we have the same kind of issue here. If you look at the curricula by these universities, so here we listed CMU versus Columbia. You kind of look at them and you say, wow, one of them is focused on machine learning, the other is much more on statistics, almost like completely different worlds in terms of the training, even though the outcome here is a Master of Data Science. BYU and Winona State, just to sample 2 others, similar things, right? Heavy emphasis on database technology, on some statistics and linear regression. The other one is much more around kind of data science and visualization, etc. So again, you look at it and you say, why? Why do they have to vary so much on content if you come from different universities, right? Online certificates, exactly the same problem, right? You look at what Udacity gives you in Intro to Data Science versus what Coursera gives you in Intro to Data Science. And we'll come back and comment in Hamid's section around what employers think of these kind of online courses and what the experience has been. But the point here for this discussion is the variance is also very, very high, right, between these online programs. So even if you kind of studied online, you'll probably get training that's very, very different depending on which online course you decided to, or program you decided to follow. As a result of the skill gap and confusion, you basically are seeing a lot of wasted time and effort in the industry. IBM did, I think they published this in 2018. Yeah. 2017, right?
Oh,
And, yes?
let me say there's a couple of comments.
Yep.
So one is, it sounds like you're saying diversity in backgrounds is a bad thing.
No, what I'm saying is it's absolutely good to have the diversity in background. What I'm saying is, if you look at these jobs, if they are all described the same, if they're all given the label data scientist, and they are so different in background, then how will a candidate know which job is for them and which job is not, right? If the diversity is so high, you actually don't know which ones are you qualified for. By the way, the confusion is even bigger at the employers, right? We argue actually the employers don't really know what they're looking for, right? They want somebody who can do the job, but what is the job? How do you describe it? What should they know at a minimum? What we believe fundamentally, and we're publishing a paper on this one at the Harvard Data Science Review, the next issue, that talks about kind of the body of knowledge and the various categories. We'll talk some about it today, of what should you expect at a minimum in the core to have a data scientist know. Now you can have a lot of variety, but just like in kind of, there's a core that should be expected and should be there and should be solid, because if you don't have it, there's a danger. And it's okay to have the diversity if you call the job something different, right? If we start subcategorizing, this is a data scientist with, A, type B, type C, type D, then you can eliminate a lot of these problems we have.
Kind of like be a doctor before you become an oncologist, or you are working with babies or different specialties.
Yeah.
You have to have a basic line of being a doctor, medical doctor first.
Yeah, or I mean, let's take even engineering, right? There's a core set of things that you're expected to know as an engineer, and if you don't know them, it's trouble, right? whether you're a civil engineer or a mechanical engineer. Now, there's also specializations where you go different, but in general, there's that core. So part of job one is let's figure out what that core is. Part of job two is let's figure out what the different types are, so we can say, you know, mechanical engineer versus electrical engineer versus civil engineer, right? Right now, you just say data scientist.
Right. A second question from the audience, from BB. What do you mean by a math question in an interview? Or can you give an example?
Yeah, I mean, you basically could ask a question around math, you know, a mathematical modeling question, or a I'll tell you my favorite question, honestly, is around trying to figure out quickly whether somebody understands what probability distributions are, and if you were given a mixture model, meaning a distribution which is a mixture of several distributions, how do you use it? What does it mean? It could be around, you know, if you're testing somebody on nearest neighbor algorithm, right, which is find the k elements in the database or the k items in the database that are closest to this item, right, which is one of the learning techniques. Well, guess what? You can immediately start asking somebody about, you know, Euclidean norm, L1 norm, you know, what's a medioid norm, etc. And if they don't know the basics in math, they get into trouble. If they can't map in their head that, okay, so what does it mean to define a distance over, say, individuals, right? And how do I write a formula if I took the Euclidean norm, right? The sum of the squares of the distances, say, normalized by the max. Well, guess what? Are you saying that age is one dimension and income is another dimension, and maybe years of university is a third dimension, and those can be compared to each other, right? A lot of people just use things blindly without thinking about the space that kind of they're embedding the problem in and the transformations they need to go through. So that's what I mean here. There are many math type questions that are very relevant to a lot of what we do, say, in machine learning or in probability theory or in data science. And those are the types of questions. They sometimes go very basic just to see if somebody gets it, right? Any other questions?
No, you're all caught up. Thank you.
All right. Thank you. So where I was heading here is this confusion, right, actually has a cost. So not only is it, and you'd expect this, right, it's harder to find a data scientist. In fact, they say it takes 5 days longer, so about 12.5% longer than a normal job. It stays open. But the churn rates are higher, right? So you basically ask, you know, what are the likelihood of these people to leave, right? Data scientist is about 10%, versus machine learning engineers or specialists, 12%. Versus if you compare that with a software engineer at 4%, or a sales rep at 4%, or an accountant at 2%, right? And you can see that difference, and that's driven by the demand. So not only have I spent more time and more energy trying to find this person, but they churn on me, you know, 2.5 times more likely than a typical engineer, right? The second thing is this comes at a cost, right? So it's one of the items we attempted to estimate is kind of just, you know, I went down the path of trying to estimate the cost of hiring the wrong candidate and how often it happens. And I got numbers that are pretty scary. But this one is just to give you an idea, right? If there are 2.7 million job openings in 2020, right? And if you kind of focused only on the 700K kind of fast growing roles, right? And if you basically said, because a lot of people claim to be data scientists, and because companies don't really know what they're looking for when doing data scientists, when they're looking at, you know, 50 to 100 candidates, the guy we quoted looked at 60. What if one of them that slipped through for an interview was the wrong candidate, right? Meaning unqualified, meaning we could not a priori tell that this person possessed the core skills or knowledge that we would expect a data scientist for this job to have. That one day, right? And I assume you do a 1 day of interviews, which means you have a full day. They come in, they meet with a bunch of people, they leave, right? That cost of that useless meeting multiplied by a typical kind of cost of the staff and engineers and HR involved, that results in about 2.7 million days in the US wasted, which is about $1.2 billion if you turn that into dollars, right? So this is significant. This is important to fix because it's costing us, it's costing the economy a serious cost. Besides frustration, besides potentially killing the field itself. We also looked at, we took kind of a deeper dive on the root causes of the confusions on the skill gap. And one day I'm going to fix this slide because it's still confusing and we will find a better way of presenting it. But basically, there are 10 challenges that we found on the part of candidates and on the part of institutions or recruiters, recruiting companies, employers, right? So candidates basically say, look, the lack of mentors basically restricts our growth, right? Similarly, in a company, they face serious retention challenges, right? Because junior data scientists come in and leave fairly quickly. There's an unclear mandate, which actually affects my performance, says the candidates, right? And that's matched by, at the employer side, inefficient utilization, right? I keep going down the left here. How do you prove your expertise, right? Mostly they are self-claimed experts and with self-training, and we'll come back to this point. This is a big weakness. Too many options, right? Too many universities, too many degrees. And the problem is that it's not like if I took it from University A or University B, I'll know the same thing. You will know very different things. And then the diversity gaps, right? Not enough females, etc. The same kind of issues arise with ineffective selection at the employers, right? The recruiters don't understand the needs. The job postings list 5 or more different data science skills. 52% believe their company culture is a barrier to AI adoption, as an example. So in that sense, it's hard to bring in somebody who's going to utilize AI and machine learning. And that leads us to kind of a common ground that needs to be defined to facilitate the discussion in the ecosystem, right? Be it at the community, universities, which I claim are just as confused as employers, right? Training centers, recruiting agencies, all of these different communities or stakeholders need to have that common language. And this is what we believe are the standards that we're helping emerge through our initiative, because that's when you can kind of start identifying problems and addressing them and saying, aha, I get it. You need the candidates to know at least these topics. As a university, I could make sure I cover those, or as a certification, I make sure I certify them on this. Same with a business. I expect these candidates to have these kinds of knowledge, etc., instead of wasting my time hiring the wrong people and kind of ruining the reputation of the field. So our initiative is around coming up with data standards around job titles and roles. That will be the subject of our second paper that will come out hopefully soon as well, out of the initiative. Knowledge and skills requirements, which we're covering kind of in the first paper that's coming out shortly at the first at the Harvard Data Science Review, but we'll have a longer version elsewhere. And then finally, assessment and measurement, which is a third area that kind of needs some serious tackling, which is how do you actually get more systematic around assessing and measuring whether somebody knows the knowledge and skills that they're supposed to have, right? Do they have them? And then how do I fit them in these titles and roles that can be mapped to these various knowledge and skill requirements? And then, of course, assessed. We are working on the standardized assessment framework through industry collaboration. So we've done a research study that Hamid will talk to you about and share with you the results of a survey, as well as a whole bunch of interviews we conducted. We've been reaching out to the community, giving talks and holding workshops at IEEE, ICDM, at the KDD conferences, We have one coming up that we'll tell you about. We've spoken at the Strata Data Conference, at the Open Data Science Conference, Predictive Analytic Words, and many other places, forums like these, meetups, etc. We have an advisory board, and you can go to IADSS.org to kind of see who they are. And some of these people are very passionate and very active in the field, and they care a lot about how to define data scientists, and including, of course, Greg, who's on our advisory board, how to define them, how to relate them to various fields, how employers should think about them, how universities should think about them. So we think we have a well-represented advisory board, and it's growing over time. So if you're interested, definitely contact us. We've used several data sources. We've done a literature review, and the two papers will actually cover a lot of that literature review. So I'm particularly excited about the paper that's about to come out because it has a nice set of, it captured a lot of what was written in this area. We've done a LinkedIn analysis, literally over kind of millions of people and roles. We've done one-on-one interviews in the field, and we've done a detailed questionnaire for about over 800 people that we kind of then filtered and reduced into, we've done data science on top of it to do analysis, which Hamid will share with you shortly. As expected, by the way, not surprisingly, there is no consensus out there on what data science is. People, go all the way from saying, machine learning is a bunch of hacking skills, which I disagree with, actually. Some people say, well, it's not a science, it's engineering. Some people say, well, there's these famous kind of intersection circles. Conway has one, and NIST has one. But in our KDD 2019 workshop, by the way, we had about 200 attendees, and when we asked them to define data science, we went around the room. We got basically 200 different definitions. And I'll talk about the definition we adopted, and no definition is perfect, by the way. People have been at it for a long time, and I'm not sure we will have one, but over time, we could kind of converge on the right definitions. What is agreed to on data science, though, is that you need to have to be able to do computing with data under varied computational constraints, often kind of dealing with disparate or unstructured data. It implies a set of activities that can be considered cross-disciplinary. And finally, there's a challenge usually you're trying to achieve. There is something, usually a business goal, or usually a problem around knowledge or insight that you're trying to crack. And you're doing your work in that context. If you look at, there's a build here. People, by the way, have been wrestling with this. When we did our literature review, I was surprised to find that as early as 1966, people have been talking about data science and the science of data. In fact, Peter Nauer talks about the science of dealing with data once they have been established, meaning the data, while the relation of the data to what they represent is delegated to other fields of science. So he's basically saying, statistics is the science of dealing with data, right? i.e. statistics, data science. In fact, in another recent paper, Irizarry kind of reviews a whole bunch of these older efforts and talks about how Jeff Wu in 1997 even proposed renaming all of statistics as a discipline as data science, which probably would have been good. Since that actually didn't happen, right? What happened is funny. I went back to the ASA, the American Statistical Association, and looked up at what they defined their own field in their words, right? So they define statistics as the science of learning from data and of measuring, controlling, and communicating uncertainty, right? So as a statistician, they use terms like learn from data, which to me are very vague. The measuring and controlling and communicating uncertainty is very precise, and I like it a lot because it really talks about kind of statistics is around the science of uncertainty, how to reduce it and how to quantify it. They actually wrestled with this question further. So this is their definition as a community. And they put out a statement in 2015. I don't know if you're aware of it, but it's publicized, it's way out there. The statement was on the role of statistics in data science, because a lot of people were saying, well, is statistics essential for data science, which I think it's important. But the statement they came up with, to me, was a bit disappointing. That's my personal opinion, right? They basically said there is not yet a consensus on what constitutes data science. 3 professional communities, all within computer science and or statistics, which I disagree with, by the way, because I think it's more fields than that, are emerging as foundational to data science. And they claim those 3 as foundational are database management, statistics and machine learning, and distributed and parallel systems. And to me, I have a problem with these, right? Because you could do a lot of data science without necessarily using a database management system, right? You could be doing it on files, you could be doing it on streams, you could be doing it on unstructured data. You could be, to me, statistics and machine learning, convert data to knowledge. What does that mean, right? I find that to be too vague. What do you mean by convert data into knowledge, right? And distributed and parallel systems, to me, that was a very strange reference, right? It seems a bit dated, and you could be doing, this on a cloud. You could be doing this on a single computer. You could be doing data science, of course, on a distributed system or a parallel system, but it's not necessarily required, right? So again, I find, and they say these are actually core kind of foundations, which clearly I personally disagree with. Point is, people have been working on it for a long time, much longer than we have, and it's been a question of interest. Here's our definition. We use a working definition. I'm going to come back and dissect our definition. The definition we use is using data to achieve specified goals by designing or applying computational inference methods. Okay, and I'm going to come back and kind of break down this by sentence. But for contrast, I've listed kind of 4 reasonable definitions of data science that have been out there for a while, right? DJ Patil a while back said it's the ability to extract knowledge and insights from large and complex data sets. Again, you could sit down and critique each one of them, including ours, and I'm going to talk about ours in a second. I like Jeanette Wing's definition recently in Harvard Data Science Review 2019, the study of extracting value from data. Now, I have my own issues with it, but it's also a valid view, right? It's basically, now you need to define what does it mean to extract value from data, and then what does it mean to study that, right? A field of Investopedia has the generic, a field of big data geared towards providing meaningful information based on large amounts of complex data. Data science or data-driven science combines different fields of work in statistics and computation in order to interpret data for the purpose of decision-making. This, to me, is not much of a definition other than saying, kind of characterizing it. Hal Varian has a nice, interesting definition: to understand data, to process it, to extract value from it, to visualize it, and to communicate it. So this is what you do as a data scientist, right? It doesn't quite say what is data science or not. So let's go back to my definition on top here: using data to achieve specified goals by designing or applying computational inference methods. So what do I mean by these terms, right? So first of all, using data. Here, data can be structured or unstructured. It can be metadata. It involves data representation, cleaning and transformation, data collection and preparation, entity extraction, etc. Right? To achieve specified goals, and this is where I'm distinguishing it by saying you got to have, what you call data science has to be in the context of a certain goal you want to achieve. Right? Now, if the goal is to kind of do a prediction, then you're kind of applying machine learning or statistics or any of these data science methods to do a prediction. If the goal is to actually understand how an algorithm works, which is that comes in the designing part, then you're actually studying how the algorithm is working and why the algorithm is working, right? But anyway, your goals that you can achieve can be business goals, can be exploratory goals, can be discovery goals, can be optimization goals. Designing or applying means designing inference methods, e.g. study of learning from data in machine learning, or applying them, e.g. just taking a standard statistical technique, applying it, and reaching a conclusion. And finally, computational inference. What do we mean by that? Well, it's basically conducting a search for a model of the data, for a structure, or for an explanation. It can be achieved through analytical, statistical, or machine learning tools. And the inference can be conducted algorithmically, right? Most of the time we expect it to be done algorithmically, but it could also come from kind of a human leveraging data visualization, other things, and then applying, in this case, computer-aided visualization and or summarization to do an inference, right? So that's what we mean by data science, using data to achieve specified goals by designing or applying computational inference methods. By the way, the one-on-one interviews came up that, and by the way, I'm going to turn it over to Hamid shortly. He will talk to you about the survey and some of these interviews and the commentary we get. But it basically, people have brought up a lot of issues, right, revolving around the inconsistent actual skill sets and how they're progressing in these roles, being a challenge, resulting in a lot of frustration and cultural impact. One of them made a comment which I like a lot. I take courses and certifications on platforms like Coursera as an expression of interest rather than expertise, which again is good. It shows that you're interested in the field. It doesn't really quite show that you're a master of it or that you have the skills. In some cases, people think statistics are important. Some people think math is irrelevant. Some people think it's very relevant. We've seen folks create a bunch of beautiful dashboards, and cost of tools has gone down precipitously over the last 20 years. But that doesn't mean that you know what you're looking at or ensure it won't be misused or misinterpreted. Same thing on the data science front. The most important thing is not being able to use an algorithm that you picked off a tool, but to know how and why you're using it. I actually couldn't agree with that more. Often, if you don't understand the properties of that algorithm and how the algorithm works, you could actually do a lot of damage using it. So with this, I want to shift gears now, unless, Greg, there's a few questions to answer, and hand it off to Hamid to talk about the questionnaire and some of the analyses we conducted and some of the findings we found.
Just one comment. Danny O'Neill said, I believe the reference to knowledge from ASA is the economics definition for knowledge. So that was just more of a comment than a question.
Getting knowledge from data is basically look up the definition of economics for knowledge.
I believe the reference to knowledge from ASA is the economics definition for knowledge.
Okay. That's useful. I'll look that up to see what they.
Okay. Thank you, Danny.
All right. Yeah. Hi, Usama. Thank you. Can everyone hear me? Greg, are we good?
Yes, absolutely.
Okay, perfect. Good evening, everyone. So I just want to pick up quickly from where Usama left off. So, this is a slide that you saw a bit earlier. So Usama covered a couple portions here, and I'll cover the rest. So he talked about literature review, right? Something that we took very seriously. And in the first report, I think this is really the most comprehensive look at how people have, gone about defining data science and the skills and knowledge associated with it. Usama also talked about one-on-one interviews. So I want to talk a little bit about the LinkedIn analysis and the questionnaire, right? So the next slide, and before I go into LinkedIn, and this maybe points back to a question we received earlier about what do we mean by math. One of the things that we did as part of the first report that Usama mentioned, that's going to be published at the Harvard Data Science Review, we lay out what we call a knowledge framework, a detailed list of what kind of knowledge can be associated with data science in general, right? So not a single person having to know all of these, but collectively, if you imagine a team of individuals, what are the knowledge areas that they need to cover in order to, to accomplish data science tasks. And when you look at the Venn diagram, it does this at a very high level, right? Very roughly. So it talks about hacking skills. It talks about, some science and programming related skills, etc. What we've done is we made that a lot more detailed and a lot more concrete. So when we talk about statistics, for instance, so when we say statistics is important for data science, but what kind of statistics, right? What exactly in the body of knowledge for statistics would be relevant to data science? So that's what we try to do in the knowledge framework. Of course, this will be up for discussion, right? We'd love to receive feedback once the article is published, so that we can make sure that we haven't really missed anything that is relevant to data science. And the knowledge framework lists these under 11 main areas, 42 subjects, and a couple hundred topics. So quite a bit of detail. So the next slide, talks a little bit about the LinkedIn stuff. So what we did there is two things. One is we looked at actual profiles of people who are working in data science and saw what kind of skills and experience they list in their profiles, in their public profiles. So we have several thousand people that we've looked at and try to summarize. And the other thing is we looked at job posts on LinkedIn from employers. So, hundreds of them, for data scientists, data engineer, machine learning specialist, etc. So whatever titles, are relevant for data science, we wanted to see how employers define those roles, so that we can kind of compare and contrast with the kinds of skills that people actually have in the marketplace. And as you might have experienced personally, some of these job descriptions can be quite unrealistic in terms of what kind of skills they're expecting. There are famous examples of someone or an employer looking for a type of skill or a programming language that has been only in existence, say, for the last few years, and they're looking for someone who has experience in that particular technology for 5+ years, which would be, technically impossible. So we also have many examples of job posts from, from employers. The next thing we did is a survey, right? So this was done over the last year, basically 2019. We wrapped it up towards the end of the year. The last couple of months, we've been analyzing our data, and that's going to go into the second report. What we did in the survey, it's a really long survey. If someone wanted to do this, complete the survey for a couple of data science roles, it would easily take more than half an hour. So we're really grateful for the several hundred people who actually, went through the effort of completing it. We tried to get an understanding of a few things in the survey. One is some insight about their analytics and data science teams, their training, development, and hiring practices. We asked them what kind of roles exist, what kind of job titles exist in their organizations. And then the main part of the survey that took a lot of time was we asked them to rank or to rank each skill, and we listed about 50 of them, and see how relevant or how important they thought for a particular role. So if they said, we have the title data scientist in our organization, we asked them, to mark 50 skills in terms of their relevance to being a data scientist for that specific organization. Which was, which ended up becoming a really large, data set. And I'll now walk you through first the profile of who actually filled this in, and then, some early results from our analysis. So as I said, several hundred people from hundreds of organizations, large and small, from a wide variety of geographies and industries. This went out to data science analytics executives, also as well as professionals, so practitioners of data science. Now, a couple of statistics from the profile and survey. So we first asked them the industries they're in. Not surprisingly, we had a lot of technology companies, but also plenty of banks, insurance companies, telcos, manufacturing companies, a lot of consultants, etc. So a good representation of the variety of industries out there. We asked them if you can, the geography is about half from North America. We have a good representation of people from Europe and Asia. Next one, please. So we asked them how large their companies are. It's slanted a bit towards larger companies, as you can see, but that's expected because a lot of the large employers tend to become large companies. So many companies with 5,000 people or more. So a lot of the banks, the tech, the telco companies, etc., that you saw in an earlier graph, but plenty of startups and mid-sized companies as well. Then we asked them about the structure of their analytics team. So how many people are in their analytics and data science teams? So again, not surprisingly, plenty of large teams. So roughly 20% of teams of 300 people or more, but also many companies with fewer than 5, 5 to 10, etc. So again, a good representation or distribution in terms of team size. Then we asked them about their outsourcing practices. So, what part or how much of their analytics work, data science work are they outsourcing? This was a bit surprising. I mean, we saw that many companies actually, or many of the people that at least answered the survey, they're not really doing much outsourcing. Means that most everyone is trying to build strong internal teams, at least in our sample. Next up, we asked them about the function the analytics group or the data science group fulfills in the organization. People could mark more than one option here, but we asked them whether they were responsible for building products, providing guidance for decision makers, which ended up becoming actually the top 2 functions. So a lot of people building data science products for production, or either for their clients or for internal users. And then we asked them about the location or the structure of the analytics group within the organization. So number 1 here was a hybrid organization. So again, typical where you would have a dedicated analytics group, typically acting as a center of excellence, but also you have built-in teams within business groups. But again, we saw a variety of organizational structures when it comes to handling data science. Then we asked a little bit about their training and hiring practices. So this was the most, I think, the most troubling finding. So we basically asked them what primary training and learning methods does your team use. Number 1 was self-education, right? And number 2 was on-the-job training, informal. I mean, what we typically, can guess is that, when someone says on-the-job training informal, it's basically ask the guy or your girl sitting next to you, and if they have time, maybe they'll explain. This is troubling because it shows that, maybe because of the pace at which companies need to do analytics and data science, there's not maybe much time for dedicated learning and development. But it also, would probably worsen some of the problems we mentioned earlier. In other words, if you're getting people from a variety of backgrounds with different skills and you put them on tasks and you're kind of leaving them on their own to learn, self-learning or informal, on-the-job training, then, you might actually be multiplying some of those problems that we mentioned earlier. We also asked them what kind of resources they're relying on. Number 1 here, again, somewhat troubling. People said, blogs, community forums, fewer people relying on academic sources or academic conferences, for example. Then we asked them about their hiring, performance evaluation practices. So for the 3 types of hires, data science, analytics, and BI, we see different practices in terms of evaluating candidates from outside. For the data scientists, which is that orange bar, you'll see that companies rely on all 5 types of evaluation. So number 1 would be an HR screening. Then you would have a case study type of interview. Then you would have 3 different types of technical evaluations. One related to domain. So you're making sure that they, if you're say hiring into a credit risk scoring kind of a role, then you want to make sure that they understand the KPIs and the terminology, etc. when it comes to the credit domain. The second type of technical interview, is say about statistics or ML or math, maybe some of the more theoretical knowledge that the candidates needs to have. And then the third technical evaluation would be around specific programming languages or specific technology that you're expecting the candidate to know. So that again ties in with the earlier information that Usama shared, where it takes much longer for companies to evaluate talent when it comes to data science. The bar is somewhat lower for analytics and then a bit lower for BI, as can be expected. And then when we ask them about how they evaluate their employees for performance or promotion, etc., again, not surprisingly, people look at business results, management's feedback, management observation, and peer feedback, but much less reliance on outside evaluation or certification or specific milestones that a person needs to hit technically before you consider them ready maybe for the next position. So this is about the the profile of people who filled in the survey. I think Usama, we've covered this slide already. So if you can just go to the next one. Perfect, thank you. The next question we ask them is, what kind of titles exist in your organization? And again, people would mark many titles as it's relevant to their particular organization. Number one was data scientist. 79% of our sample actually said they have that title in their organization, followed by data analyst, data engineer, BI analyst, analytics manager, etc. So I think this is the top 15 or 20 here on this list. But the creativity when it comes to titles is quite impressive. We saw many titles that are not listed here, which was some of them was quite interesting. We start seeing titles such as data translator, data prophet. Like I said, I think there's really no limit to creativity when it comes to coming up with titles, but these are the top 15 or 20. As I said, the majority of the survey focused on the skills and knowledge that people were expecting these variety of titles needed to have. So the first exercise we did was, how are those skills grouped when people are answering these questions, right? So if someone ranks a particular skill highly important for a role, what other skills are typically rated high, right? So which skills go together? So you can think of these as almost genres of music, right? So for example, the orange box there, reporting and visualization. So people typically, tend to rate spreadsheets, reporting tools, data summarization, etc., important, for a particular role. Or, when you look at that light greenish box with the large SQL text, you see SQL typically goes with relational databases, enterprise relational database management systems, etc. So that's how skills are grouped naturally. Next up, we actually looked at how these skill groups relate to particular titles. So, for example, so obviously the red circles here denotes that this particular skill group, prototypical skill group, is important for that particular title. So when you look at the ML scientist, ML theory is by far the most critical skill set group for that particular role in the organization. Or when you look at, say, a data analyst, fourth from the top, you'll see that reporting and visualization, communication and collaboration, and basic analysis, data preparation are the most critical, skill groups. For data engineer, actually, you see a much larger sample or larger, requirement. Let me say, they need to understand big data. They need to understand ML ops. They also need to understand data engineering skills, also communication and collaboration, and then also understanding relational database management, systems. So this gives us an idea about how people, link these prototypical skill sets to particular titles. The most complicated, honestly, was the data scientist title, right? So people who are self-claimed data scientists. When we looked at the skill sets for this group of several hundred people who call themselves data scientists, we saw a huge variety in terms of what kind of skills they're expecting from, from the same title. So there were three main clusters, basically, if you will, within this self-claimed data scientist group. So, for instance, the first group of people were expecting, data scientists to know a lot of things from most of these skill sets that I mentioned. So the longest part that you'll see, so the first data scientist group, you expect them to know, data science and ML, reporting and visualization, ML theory, they need to be strong in communication and collaboration. They need to be strong in basic analysis and data preparation, etc. So it's a very high bar to meet, right? This is probably fairly close to what people would call a unicorn when it comes to, listing requirements for a data scientist. But when you look at the third group, DS3, this is again, these group of people, they're also called data scientists, but the bar for them in terms of what they need to know is significantly lower, right? So they need to know only a little from all of these, the 10, skill groups. So that, kind of sums up what I guess what we've been trying to say tonight. That is, particularly when it comes to the data scientist title, the variety of skill sets that people have and what employers are expecting data scientists to do, it's all over the map, which is creating all of these problems that we've talked, about, and you can see this very clearly in our survey. Now, during our analysis, what we're trying to do is actually, can we define these personas, these data analyst persona, the data engineer persona, and maybe a couple different personas related to the data scientist, and can we standardize those so that people can converge around certain types of definitions rather than these definitions being all over the map. We think this would make it much easier, as we mentioned earlier, for people, to match basically demand and supply, if you will.
Did you have names for these clusters then?
Excuse me?
Did you have names for these clusters? DS1, 2?
We haven't named them yet, Greg, but the top one, I think, is what people, like I said, informally call a unicorn. I mean, that's not a title, obviously, right? You wouldn't have that title in your organization. So that needs to be a senior level of data scientist for sure, say, compared to DS2 or a DS3.
I think DS3, we pretty much know is more junior data scientist and generic, and cluster 2, DS2 is more kind of on the data prep and engineering and development side, as opposed to statistics and machine learning and analytics. But of course, we got more clusters than this, but the whole idea here was to kind of go deeper and see behaviorally what sticks out the most in terms of within the data science cluster.
Exactly. It might be interesting to see them displayed as, in terms of standard deviation, what's above average and below average for the DSML kind of thing across the clusters or something like that.
Yeah.
To help distinguish a name.
Yeah. So that's all we wanted to share related to the data collection and the survey efforts. Unless there are any questions, I want to move us to our conclusion, basically. One thing that we wanted to share that we thought might be relevant for this group is, as Usama mentioned, last year in Anchorage at KDD, 2019, we held a workshop, our first workshop on, on this topic. Very well attended. It was great discussion. So we were encouraged by that. So we're going to organize another half-day workshop at KDD 2020 in San Diego. Of course, we're not sure how that's going to happen. It's going to be full virtual, full on-site, or somewhere in between. We're waiting to hear from the organizers. But for this workshop, we're going to focus on training data scientists, right? So it's going to be co-chaired by Usama and Li Meng, who is the founding editor-in-chief of the Harvard Data Science Review. And the discussion will be around how we can better train data scientists with the skills and knowledge that the industry needs. And we want to explore how industry and academia can collaborate maybe a bit better on this. They're going to be invited talks, panels, discussion sessions. And we want to hear from, the educators, obviously. So administrators and educators from leading institutions, colleges, universities, as well as industry executives responsible for managing and, hiring and training data science talent. We also want to make sure that there are people from training boot camps or in-house training programs from, companies. And Greg, you'd mentioned earlier that, we could potentially share a link or a survey after the talk. So what we want to do actually in getting ready for the workshop, we want to understand the training practices in the company. So what kind of platforms, what kind of sources, what works better when they're evaluating candidates, which training programs are more important maybe than others, etc. So we'd love to maybe pick the brains of this meetup group and get some data from them so that we can maybe present some original data during the conference that's going to happen in August.
Yeah, we'd love to support that. There was a few other questions on the Q&A board. I apologize, I hadn't been on the Q&A board. Stephen said, apart from job titles, one main distinction about companies is A, whether data scientist includes people who create ML and data engineering infrastructure, or B, those who are separate in-house teams, or C, company uses drag and drop workflow tools. So he was asking about in the job titles, kind of a distinction between what you're looking at for data scientists. Do you want me to read it again, or?
Yeah, no, I also see it on the screen. I mean, it's a great comment. You fully agree, right? And I think that's creating a lot of confusion. There was, in one of the earlier slides that Usama shared, there were some job posts, right? Sample job posts. So the company, for instance, that uses drag and drop workflow tools, the kinds of skills that they would be looking for in data scientists would be significantly different than, the group that's, Stephen mentions as people who create ML and data engineering infrastructure. And our thinking is that, those two people, they might both be very valuable to their organizations and they're both needed, but they probably shouldn't have the same title and shouldn't be, considered performing the same function.
Yeah, and then Steve had a second question, or, do most companies need both a separate data engineer and ML engineer or not? Or he was asking, are many people moving to drag and drop instead? I assume that means for more data workflows, so it's less data engineering.
Maybe also referring to auto ML, probably.
No, I think this is more for kind of data prep and data sourcing and
right.
I think so I definitely would like us to evolve towards, there's clarity, difference between a data scientist, a data engineer, a machine learning engineer. It's a lot of these roles, right? And well, I would expect, for example, the problem with the drag and drop is up until now, we haven't been able to get to a world where drag and drop is enough to kind of deal with access to data and the right data transformations to get them in shape where a data scientist can use them. I think we will crack that problem over time, but I think to this day, it seems like most companies, and in fact, I could talk about it from our own projects, we definitely need data engineers, and we definitely need kind of machine learning programmers to support or to help with the heavy lift that a data scientist has to do. The first category of data scientists, the ones that Hamid was calling as kind of unicorn, those are the guys who are like very strong programmers, but also have very deep statistics and very strong machine learning knowledge. And they can do a lot of data transformations, right? So, and you can tell already if you've got these skills, you're going to be in super high demand, and it's a very rare combination. But what we found is kind of data scientists tend to specialize much more into the analysis and the algorithmic kind of exploration side of it, whereas they're pretty weak when it comes to kind of data engineering skills, like core data engineering. How do you make, you know, a big data thing work on the cloud? How do you, you know, make loads work at scale, all that kind of stuff. And of course, machine learning engineering, where you have to do a lot of programming to get the pieces to work together. But I think over time, as the tools get better, hopefully we will converge on one role.
Okay. And then a last question from Sunil. How does it vary from country, domain to domain on the study? I think on the questions, like you had breakout of different kind of questions and attributes, but was there any kind of breakout of across the countries?
We saw some variation. We're not focusing on it, at least not for the purposes of this study. But in the report, we'll point out to a couple, more significant maybe differences. Domain is a critical topic, and probably one of the things that we discussed the most, and still continue to do so. I mean, we try to keep our approach domain independent, mainly from a pragmatic, perspective, not because we don't think it's important. It is hugely important, right? And a lot of people will say, what you do, say in a healthcare setting versus, say you're an actuary in insurance versus say you're a biostatistician. Obviously, what you'll need to know will be different. But at least for this study, we're trying to focus on what makes, what are some of the common attributes or the common traits of people working with data science, regardless of the domain. But we think further iterations of this study, and maybe other people can collaborate on this. There could be subgroups that are working maybe for domain-specific applications of data science. And there will be some differences, but we see a lot of, there's also a lot of common things, right? So a lot of the main categories that we talked about, such as statistics and math and computer science, etc. We see that there's also a lot of commonality that is not specific to any particular domain. I don't know if there's anything else you'd like to add, Usama.
No, I mean, that's a good answer. I think while there were some subtle differences, I think all in all, kind of, it doesn't vary too much by country, but we haven't looked at it in depth. So,
and then have you seen roles that were just relabeled as data science roles? I don't know how you would check that, but if, I guess 1 month they had a job X for a certain company and they just renamed it to data science in month Y.
No, there's actually there's a famous quote on this. The head of data science analytics at Lyft. He went. I think it was on Quora or some public forum where he said it was becoming really difficult to attract talent. So we renamed all of our data analysts to data scientists. So I think a lot of this is Lyft, right? I mean, very obviously respectable company. They do a lot of deep dive into data, for their core product. So I think this is common practice as employers are trying to attract talent. There might be some title inflation, and that might be driving some of this confusion, in titles that we're seeing.
A question more from me. I've seen somebody that I was interviewing for in a data science role I was hiring for, labeled as a senior data scientist with 2 years of work experience. Any comments on some of the unexpected things? You've been coming from a small startup, and I suspect there was some title inflation to make up for lack of salary, perhaps, since it was an early stage startup. But any comments or observations on what's senior in other professions, like in engineering, mechanical engineering, or other types of professions compared to data science?
I'd say anything, 5 years plus right now, I think in this domain that we're all operating is quite a lot of experience, maybe unlike some other fields. So clearly, I wouldn't agree with calling someone with 2 years of experience a senior data scientist. But there, on the other hand, I mean, while saying this, I want to qualify it by saying is our approach is that we should be looking at what the person actually brings to the table, right, in terms of their skills and knowledge. And that can be quite independent from number of years of experience.
Sure.
Right. So I guess it's a balance. On the one hand, number of years could be indicative of certain types of skills or qualities you'd be looking for. But I think in data science, it has moved so fast and some people have acquired knowledge independently or by being thrown into really difficult challenges, that they develop significant skills over a shorter period of time. And that's okay, so that's why we think focusing on knowledge and skills is important, so that becomes an objective way of comparing people or talent or seniority even.
Yeah, that certainly makes sense. Meritocracy.
Okay. Are there any other questions?
I'm not seeing any other questions. Does the audience want to share any other questions? Okay. Any last comments or closing comments from either of the two speakers?
Yeah, so I mean, I hope this was useful. I also hope that the KDD workshop will be in person in San Diego. If we're not traveling to conferences by August, not only will I be saddened, but I'll be very disappointed and surprised. So but I hope to see many of you there. And hopefully this is useful. If you have other questions, please, by all means, send, and we'll kind of follow up with maybe some surveys and data collection.
Yeah, we'll be very happy to send that out. And also, there's the LinkedIn group for IADSS or IADSS. And so then that's the way people can get involved if they want to. And then also just in general, if people want to get in touch with SFBay ACM, then there's ways you can get in touch with us on the meetup group. Just express your interest to reach out and join us if you'd like to help organizing in a local meetup group. There's a variety of different things.
Okay.
Emmett, did you have any closing remarks?
Thanks for having us, Greg, and thanks everyone for staying so late.
Yep. Thank you.
Thank you very much.
Okay.
Okay.
Take care.
Bye-bye.
Okay.